get answered. Mathematical literacy, conversions, and time. We shall look at this. So for question number 1, we shall start with this chart here that we see. The weather chart below shows different weather patterns for a week. Study the chart and answer the questions that follow, or the following questions. Forecast for Polokwane, represented by Polokwane district. Right, today, when you look at this, when you take a look at this, which day do you think it was this? It has to be a Monday. Why? Monday is the only day that's not showing here. So it's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Anyway, here we go. This is when it was taken, sunrise, and all right, detailed forecast for Polokwane represents by. Okay. They ask us which unit of measurement is used to express temperature in South Africa. Remember, we have two types of temperature. One is Fahrenheit. One is Fahrenheit, and the other is what? So these are degrees. So one is metric. So we use this. This is the metric one, and this comes from what we call the imperial. This is under conversions. Imperial, when we look at the measurements in the olden days, so yards, feet, inches, that's imperial. And we look at metric, we look at kilometers, meters, centimeters. So here we are looking at, it says the unit of measurement, we shall say degrees Celsius, so you can write it in full. Degrees Celsius. Write down the days write down the days with the model maximum temperature. Model, number that appears most, way, maximum. So this is the maximum temperature. Which days have the, so when you look at 21, 29, 26, 29, 29 has appeared twice. So it's the mod there, 27, 22, 20. So which days are these? All right. If this was Monday, then you have Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So which one? Okay, allow me to come back here. Look at that. So it's Tuesday and Thursday. So the 2 days that we have a model number. It's Tuesday and Thursday, according to this chart here. Calculate the range of temperature on Friday. When we look at range, what comes in our head? Range will always be the highest value minus the lowest value. So simply meaning we shall take the maximum temperature minus the minimum temperature. So what's the minimum and what's the maximum temperatures on Friday? Let's go there and we see. Now these are the maximum temperatures that we have, and these are the minimum temperatures that we have on Friday. On Friday, we had 27 as maximum and minimum as 7. All right, then we shall come down here. We shall write 27 minus 7. So your answer becomes 20 degrees Celsius. That's the range. That's the range. All right. 1.1.4. Convert 29 degrees Celsius to Fahrenheit. Round off your answer to the nearest degree Fahrenheit. Guys, the moment you see that there is a formula, all you do, you try to substitute into your formula, right? The formula says Fahrenheit. The formula is for Fahrenheit. We are converting to Fahrenheit, which is okay. We don't need to substitute. Meaning, we need to where you see the C, you put the given temperature. Okay, the rest are okay. So here, open your brackets. 29 times 1,8 into. You understand? You close the brackets and you put everything. Now, when we multiply the 29 times 29 times 1,8, you have 52,2 plus 32. The answer became 84,2. But take note, they said to the nearest degree Fahrenheit. So simply meaning we don't need the decimals. So here the answer is supposed to be 84 degrees Fahrenheit. All right. We'll look at question number 1.2. 1.2 looks at different kind of foods that we have here, provided by, I don't know, it's Tan. Let's read here and you see. Tando is a member of a Stockfeller group who resides 47.5 kilometers away from the nearest supermarket. Below is this description of items they frequently buy for their Stockfeller. All right. We have Tastic 10 kg rice, that much. We have 50 kg of Samp, then we have 150 grams of Lucky Star Pilchard. Okay, that's what you usually buy. So now we here 1.2, 1.2.1, they ask you to change kilograms to grams. Remember, we have kilograms. We want them to become grams, or they should become what? Milligrams. But in between these two, we have 1,000. Also in between these two, we have 1,000. Don't forget, big to small, you divide, whereas big to small, multiply. Big to small, multiply. Whereas small to big, you need to divide. You need to remember, we are saying big to small, multiply. Whereas small to big, you need to divide. Small to big, you need to divide. Anyway, so we are in between these two. Kilogram to gram. So we are heading to the right-hand side, simply meaning we are going from big to small. Big to small. Because a gram is smaller than a gram. So we need to multiply by what? By 1,000. So you come here, you take that, multiply by 1,000, and the answer became 5,000 grams. You may not write the word grams, but grams, you write the G. 1.2.2, Tando loves to give food to the less fortunate in small quantities of 125 grams. Determine how many packets of 125 grams will Tando be able to give or to get from one packet of 10 kg Tastic rice. What we're going to do, since we are going, so we ask ourselves, okay, he has 10 kg, but the packages or the small containers where he's going to pack, they cannot take 10 kg. He's going to pack the 10 kg into smaller packets of 125 grams. So the kg has to become grams before. You multiply by 1,000, you end up having 10,000. So these have become grams. So if you have 10,000 grams, you want to pack it in small packages of 125. What do? Divide by 125. What answer do you end up having? So 10,000 divided by 125 equals to 80. So this is 80 packets. You will have 80 packets. 1.2.3. Tando stated that the return trip from the supermarket to her house is 105 kilometers. Verify if her claim is correct. What we're going to do, we shall need to go there and we see what is the distance from her house to the supermarket. Remember in the scenario that we had on top here, it says Tando is a member of a Stockfeller group who resides, who stays, who lives 47.5 kilograms away from the nearest supermarket. So let's come down. How are we going to verify that? This now, when you hear a return trip, that means to and fro, or going and coming back. Return. So you're going to multiply by 2. So it's 4.7 kilometers Multiply this by 2. You'll end up having an answer as 95. 95 what? So this is not equal to 105 kilometers. So the claim, they said verify if the claim is what? Correct. So you conclude and you say it is incorrect. It is incorrect. Tando will leave. Tando will leave home at 5 minutes to 8 to reach the supermarket at 8:20. 20 minutes past 8. Determine the speed at which she will be driving to the supermarket. Use the formula below. Yes, whenever you're given a formula, please understand, analyze it. Because now this one says, because now what am I looking for? Determine the speed. Oh, indeed, I'm looking for speed. So speed is in the right place. Then if I'm to look for speed, that means I am given distance and I have time. All right, what's my distance? Remember, she told us she lives 47.5 kilometers from the supermarket. So the distance is 40. I will not use this because this is to and fro. Here, she will leave home. Simply meaning going. They have not told us that she will return. Yes, she has to return because she won't sleep in the supermarket. But for this now, we look at this because she's just going. So what about the time? Now, time we need to know. How much will she spend on the road? So what simply meaning? The arrival time minus the departing time. When you subtract these two, you remain with 25. 25, these are what? And minutes. Remember, speed is in kilometers per hour. You see? So we change the minutes to hour. What do we do? We divide by 60. Divide by 60. Divided by 60. Whereby you get 0.4. I'll round off to 0.42. So this is time now. These are hours. So now our speed will be, sorry, the speed will be distance over time taken. Distance over time taken. We said distance 47.5 kilometers. Time was the arrival, which is 8:20, minus the time when they left. We ended up having 25. These are minutes. Change the 25 minutes to hours. You get the answer 0.42 hours. So come now and substitute distance. It's this much. Time, it's this much. So our speed will equal to 47.5, don't put the kilometers, divided by 4.2. 4.7 divided by 0.42. So the speed was 113, 10. Round off, please. That's the answer. So this is the speed she'll be using. That is the speed she'll be using. The right answer. Express the amount of fatty cheese in ounce required for the salad for the above recipe. If 1 ounce 0, equals to that much. So for us, we have 200 grams. We need to divide that and we get the answer as that much. Okay. If you look at 1.3.2, if 10 tablespoons equal to 150 mils, determine how many liters of olive oil are required for the above recipe. So now I wonder why they're asking for liters. Anyway, these are the liters. These are milliliters. You see, 10 spoons. So simply meaning one tablespoon. 1 tablespoon will equal to divided by 10, which is 15 mil. So let's go to the recipe and we see. So the recipe says olive oil, we need 3 tablespoons. So we shall multiply this by 3. You end up having 45 mils. They don't want mils, they want liters. So of the mils, we divide by 1,000. The answer becomes 0.045 liters. Tando claims that she requires 100 grams of peanut for 9 people. Verify the calculations. First and foremost, remember that the preparation that you have is for 6 people. Now you need to look for how many or how much will the 9 people take for the peanuts. So we shall say 6 people. They need how much? 6 people need the peanuts. Where are they? The peanuts. Okay, yeah, it's supposed to be peanuts, not pine nuts. These ones here. For 6 people, we have 500 grams. So we shall say 6 people, 500 grams. What about the 9? Because we need to prove. Should it equal to 100, then the person is right. But if it's below or above, it's not right. Then here we go. All right, this becomes 50 times 9 divided by 6, which becomes so we need 75 is not the same as 100 grams. So it's invalid. Let's look at question number 2. And question number 2 has time. Definitely, if we look at time, we shall also look at what we call duration. We look at duration. All right. Mr. Van Veek works at OR Tambo International Airport, and he travels to work using the bus transport available in the location of Tembisa next to the hospital, and his transport uses the following timetable. Study the timetable and answer the questions based on the timetable. All right. This is a timetable when you look at it. The first section, actually there are 2. We have section 1 and we have another section. Now this is from Tembisa to OR Tambo, whereas this is OR Tambo to Tembisa. So simply meaning this is what he uses from here to work. Then this is from work to home. Right. Why? They've told us he works at OR Tambo. So he works there. Where does it stay? It stays next to Tembisa Hospital. So Tembisa to International Airport is going to work. Then from Ayora Tambo to Tembisa is coming back from work. Anyway, we have different sections here. We shall go on and see. These are ticket sales. Where are they? Where are they sold? And open for ticket sales, close for ticket sales. So now opens for it closes the open, closes, open, closes. Anyway, let's continue and we see. Look at the questions. Identify the name of the bus company that Mr. Van uses to get work to work. Now this is adapted from City of Ikuleni Alambe Bus Services. So this is where the bus service is called Alambe Bus Services. Identify the ticket sales. Identify the ticket sale points that are convenient to Mr. Van Dijk. Remember, he is in Tembisa, so convenient. Let's come and look at the ticket sales. If he's in Tembisa, he can take from Tembisa Hospital, Tembisa main station. No, this one, no. Why? It does not stop here. It does not do anything here. Let's look at this one here. This one's not there. This one, no. This one, no. Yes, this one, yes. This is possible. Why? He leaves Tembisa, he goes to Tambo. So he can easily also buy tickets as he's coming where? Back home. You know, he reaches workplace, as he comes back, he can buy a ticket from there. Or from his workplace, from his home place, he can buy tickets. You understand? But the variable one, I think it will be Tembisa Hospital and because here they say, okay, yeah, also when it's in Tembisa, it's fine, it will work also. So the points are, we have Tembisa Hospital, then we have Tembisa main station, and the OR Tambo. The OR Tambo, where he works. International Airport. Yeah, these are the places where he can get. These are the places where he can get tickets. What time format is used in the table? What time format is used in the table? Time format. Remember, we have two time formats. One is called the analog, and the other one is called the digital format. Here, analog, we call it the 12-hour. We call it the 12-hour system. And the digital, we call it the 24-hour system. I'm reminding you of this. All right. What happens under analog, we need to see. Under analog, we expect someone to have AM and PM. Whereas in digital format, there's nothing like that. No AM, no PM. So let's go on to our chart here. When you look at the time, it actually, it's fine. When we look at the time, we have no AM, we have no PM. And when you look at the evening or afternoon, there is no the time has gone beyond 12. We have 13 hours, we have 14 hours here, 14 hours, 20 minutes, 15 hours, 20, So the time, the right answer here is digital. Why? There is no AM and there's no PM. So we shall say it is 24-hour format. Reason being, it has no AM or PM. On the table, it's not indicated anywhere. It's not indicated anywhere. All right, 2.1.4. Write down the arrival time of the bus that leaves OR Tambo International Airport at 22 hours 30 minutes. It leaves OR Tambo. It leaves OR Tambo. It leaves OR Tambo at 22 hours 30 minutes to Tembisa main station in 12-hour system. First and foremost, you want us to write the time of the bus that leaves OR Tambo from it leaves OR Tambo at 22 hours 30 minutes to Tembisa main station in 12-hour format. So we need to look at that. We shall come here. Let's check their next step. So it leaves Aratambo. We shall look at this one here. But it leaves at 22:30. So it definitely it's here to the main station. So it leaves at this time. It arrives at this time. So they want us to write this time here. This is the time they want us to write this one here. They want it in 12-hour. They want it in 12-hour system. And remember, 12-hour system, we indicated we should end with either it was AM or PM. But when you look at it, it's 23 hours, 28 minutes. So in 12 hours, 23 represents 11, 28. But when? At night, it's PM. So the answer is supposed to be 11. Right? They're telling us the arrival time. Right? The arrival time of a bus that leaves Aratambo at the same. So when does it reach this? We said there it reaches, okay, it leaves Aratambo at 20. It departs from Aratambo at 22 hours, 30 minutes. Then it arrives at 23:28. So this arrival time is supposed to be displayed in 12-hour system. So it reaches 11:28 p.m. Someone who doesn't know how we did this, we pick this time here minus 12. So we shall take 23. Shall take 23. It's 23:28. Subtract 12 hours. Becomes 28 minus 0, you get 28. So here we have 23 minus this, you get here, there's a 1, there's a 1. So this is what, don't forget it was PM. That's how we get the time to be expressed in a 12-hour system. So if it's from 12-hour system to 24-hour system and it has passed afternoon, we add 12. If it's from 24-hour system to 12-hour system, we subtract 12 and we indicate PM. We subtract 12 and we indicate PM because it was already past afternoon. You understand? When we are changing 12 to 24-hour system, this happens when the time is in PM. 12-hour system, 24-hour system. We add 12 if the time in 12-hour system had what? PM. If it was AM, it remains. But PM, add 12 onto it, and you get, so the opposite is true. So from 24, it's already beyond 12, we subtract 12. Okay, calculate the duration of the bus that leaves the hospital at 7:30 p.m. or Aratambo. Express your answer as minutes. 1. We are looking at the bus that leaves the hospital at 7:30 p.m. When does it reach Aratambo? That's the first thing. After reaching there, we need to know. Because remember, duration, how much time have you spent? So duration will always be the end time, which is the arrival time, minus the start time, which is the departing time. When does it depart? When does it arrive? So end minus start, arrival minus departure. Let's go to the table and we look at it. It's say the bus that leaves the hospital at 7:30 p.m. We go up there. But remember the table leaves the hospital at 7. So the table does not have AM, does not have PM, but they said 7:30 p.m. So it's supposed to be 19:30. Oh, wow. It's here. So this is depart way, hospital. The bus leaves at, this is it. This is the 7:30 p.m. So when does it reach Aratambo? It reaches Aratambo at 10:45 p.m. Don't mind about this. We shall use this to calculate, all right? So we shall come to to the question there. We shall say start time, end time. We've seen it as sorry, this is 8, not 10. $8.45, it's fine. But leave it as 24. So in that to make sense. So it's 20 minus 20:45 minus the starting time, which we said it was what? 19:30. How much time has it spent? So you're going to look at this and you find out that this is 1 hour, 15 minutes. 1 hour, 15 minutes. But they don't want this in hours, and they want the final answer as minutes. So 1 hour already consists of 60 minutes plus the 15 minutes that have passed. So the person spent 75 minutes. All right. Let's see, 75 minutes. How did you get this? Please, you do this. 20:45 minus 19:30. So 45 minus 30, you remain with 15. 20 minus 19, you remain with 1. All right. There was no borrowing included here. Then on your calculator, there's a key. There's a key that looks like this. It has commas, like sort of things like this. It's a key that is used. All right. So what you can do is to press 20 and you press this key. You press 45, you press the key, minus 19, you press the key, 30, you press the key. Otherwise, you press afterwards, you press the equal signs. The answer will come out the way you want it to come out. It will be perfect. Done. So it will give you the answer like this. 20:45 minus 19:30. 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 20:45 min Please, this is the answer. But then when you write it as 1, 1 will represent the hour, 1 hour. Then this 15 represents the minutes. 15 what? Minutes. 15 minutes. So if you press the SD, it will give you it will give you 1,25. These are hours. Multiply by 60. The answer will become 75. This would be what? Minutes. Take note of that key there. We say duration, time taken to accomplish a given activity. And how do you get the duration? We said the time when the activity ended minus the time when the activity started. Now, in the case of the journey of the bus which you are taking, the arrival time minus the departure time or the departing time. So they are telling us the bus leaves. That means it departs. It departs. It leaves at this much time. By the way, can you say calculate the duration of the bus that leaves and express your answer as what? So it leaves this time much time and it reaches this. So you need to know when does it reach. We went to the graph, taking the bus that leaves Tembisa at 7:30, which is this. When does it arrive at Oratam? It reaches there at 8:45, which is 20 hours, 45 minutes. So we are looking for the duration. When does it reach there? So we said arrival is 20 hours, 45 minutes minus 19. That when you're dealing with duration, please make sure that you use 24-hour system. The time has to be in 24-hour system because it will be easier for you. All right. Okay, there we go. So this one here, it gave us the answer as 1 hour, 15 minutes. Since they want the answer in minutes, we say 1 hour has 60 minutes. We add on the 15 minutes because they're already 15, they are minutes. And the answer became 75 what? Minutes. 75 minutes. Then another method, you can do it this way: 20 or 45 minus 19, 30. What is it? 45 minus 15? Sorry, 45 minus 30, you get 15. And 20 minus 19, you have 15. So this represents hours. This represents, you do the same story, which is 60, representing the minutes from the hour, plus the 15, which are already minutes, which is what? 75 what? Minutes. Yes, the other one I said is a key that we use. You look onto your calculator there. Look onto your calculator, the scientific calculator. Look for the key. It's usually above English. Ing. It's not English, but it stands for engineering. So the key looks like this. It has a small or then sort of commas. Look for that key, please. How do we use it? We shall press 20, then you press the key. You press 45, you press that key. Minus, because we are subtracting, minus 19, press the key, and you get 30, you press the, don't forget, press the equal signs. Your answer will come out as 1. One with the degree, then 15. It looks like feet, then 0. So this will be hours. These are minutes, and these are what? Seconds. But then you press the key again. No, you press from here. You press SD. This is a key. You know how to press the one that changes fractions to decimals. You understand? You press that key. It will give you 1,25. That's turned it into hours. Because everything becomes hours. But you want it in minutes. What do? Multiply by 6. You will get your answer 75. This will be what? In minutes. The reason why I'm showing you all this is to see that how you get the perfect answer. All right. Let's look at question number 2.1.6. If Mr. Van finishes work at 17 hours, he finishes work at 17. Remember, he is in OR Tambo, so he has finished work at 17. Now, another thing that we have to put into logic, when you finish work at 17 hours, you can't get a bus immediately. Why? You need time to walk to go to the bus. You remember, you're not working in the station. You understand? So here we go. It says, catch, after he catches the second bus. Take note of that. He finishes work. He catches the second bus after work. It takes him 18 minutes to walk from the bus stop to his home. That's when he reaches at Tembisa. Calculate his arrival time at home. So he has finished work. He will go for the second. He goes for the second bus. You understand? Let's go and analyze that. He's from OR Tambo to Tembisa. So when you come to the chart here, we shall look for OR Tambo to Tembisa. So when does he finish work? He finishes work at, because this one here, it's in the morning, comes in the afternoon, and then goes into evening. So he has finished at 17 exactly. If he finishes at 7, he would have taken this, but you can't, because if you finish work at 17, definitely you're not at, yes, sir? For you to reach the bus station, maybe you take some minutes. Anyway, so he takes the second, they said the second bus. So he takes this one that leaves at 17:20. You see that? Now he's going to Tembisa Hospital. So if he leaves at this time, he reach Tembisa Hospital at 18:34. After reaching Tembisa Hospital, that's his bus station, he will have to walk or to move from the station for 18 minutes. So he has left using the second bus. When does he arrive at Tembisa? He will arrive at 18:34 plus 18 minutes. Plus 18 minutes. So when will he arrive at his place? Let's go and redo that. We are saying he takes the second bus, but the second bus leaves at 17:20. So it means after finishing work, he catches the second bus. So he used 20 minutes to go to he used less than 20 minutes to go to the bus station there to get the bus. Then this bus leaves. It has to go to Tembisa where he stays, and it arrives there at 18:34. So if it reaches there 18:34, now this is at the station. He has to walk 18 minutes. We need to add them on. So this is 2, 12. So 1 plus 3 plus get 5. So it's what? So he reaches home at 8 minutes to 7. That's when he will arrive at his place. That's when he will arrive at his place. Question number 2.2. The rail transport is still a convenient mode of transport in European countries. Below is the map that shows the routes and the duration of the train from different countries in Europe. Study the map and answer the questions that are based on it. questions that follow. This is the map. Now, we see time. This is time, time, time. In other words, this is duration, not time. That's time. So from Berlin to Frankfurt, it's 30 hours, 52 minutes. Same. From Frankfurt to Berlin, it's that much. Amsterdam to Berlin, it's 6 hours, 4 minutes. You understand? This is this town is this one you're calling, but it doesn't show the time here. There's no duration. Anyway, we have time there between this and Brussels, Amsterdam and Brussels. This 1 hour. London and Paris. It's 2 hours and 16 minutes. Ne? These are the durations as they talked about it. It shows the routes and the durations. How much time someone uses when they're traveling in between those routes. Anyway, let's go there. Define the term duration in the given context. Now, here the context. Now, the context that we're looking at, it's train traveling from one town to another. European, this in Europe. Ne? So we shall say duration, time spent traveling from one town to another. Duration, the time spent traveling from one town, one town to another. Duration in this context, it's duration here. We shall say duration is the time taken to travel from one town to another town. Another town. It's a duration. All we need to say travel. Or time taken by the train to travel from one, because we are looking at trains context. All right. When we look at the context thing, part of it, we are looking at the what's going on. What are you looking at? What is in the story? How many minutes does it take for a train to travel from Milan to Rome? How many minutes? This I'm talking about how many minutes. So we go to the map, we look for Rome and Milan. Indeed, it's this. From there to here. They are telling us it's 2 hours, 48 minutes. 2 hours, 48 minutes. 2 hours, 48 minutes. So we shall say 2 hours, 48 minutes. So we shall say 2 hours, 48 minutes. These are minutes. You don't need to change them. So we change the hours to minutes. What do we do? 20 times 60. So 2 hours, we have 120 minutes plus the 48 minutes that I already spent. So the answer becomes 168. These are what? Minutes. These are minutes. 2.2.3. If the train leaves Barcelona to reach Paris at the time displayed on the clock alongside, at what time will this train arrive at Paris? Express your answer in 12-hour format. So now, hey, at what time will it reach? Now, another thing we need to know. They didn't tell us whether it was morning or afternoon. The train leaves Barcelona to reach Paris at the time displayed on the clock alongside. At what time will the train arrive at Paris? The train leaves Barcelona to reach Paris at the time displayed. To reach Paris at the time displayed. So if it's going to reach at because you need to know what time is it. Mm, it's 10 past 10. Yeah, son, 10 past 10. This is when it's going to. Because they say it leaves Barcelona to reach Paris at the time displayed. So it reaches Paris at the time displayed, which is the. So this is the arrival time. It arrives at this time. Then arrival time is that. Then at Paris, express your answer in 12-hour format. So we shall go and find out. Barcelona reaches. So from Barcelona to Paris, how much time is needed? Barcelona, it's here. Then Paris, it's there. How much time needed? 6 hours, 30 minutes. So we need to work backwards. We need to work backwards. We need to work backwards. Now, the problem is we don't know. It arrives at this time when 6 hours behind, 6 hours backwards. So we need to subtract. We shall subtract the duration time. 6 hours, 30 minutes. We need to because you're working backwards. We're working backwards. So it's 10 hours, 10 minutes minus 6 hours, 30 minutes. You'll see that it's 3 hours, 40. So this could be AM. Because if this is AM, they didn't tell us whether it was PM or AM. If it was PM, then this would be also be PM. 6 hours backwards. Let's see. Working backwards, we have 10 equals to 9 equals to 8 equals to 7. I'm looking at the durations now. Because we have 1, 2, 3, 4, 5, 5, 6, 6. So these are 6 full hours. Then 30 minutes backwards. 30 minutes backwards. What does this simply mean? It's supposed to be 4, 440. Not 340. Why do we have this 340? Because 6 full hours. Six full hours. One, two, three, 4, 5. Oh, it's not yet. Okay, at 440, these are the 6 full hours. Then when you subtract, yeah, it's the right. This is the time when it's supposed to be the time when the train left Barcelona. That's what we are looking for. What time will the train arrive at Paris? On the clock. What time will the train arrive in Paris? Explain your answer in. Sorry for that. Let's look at this. If the train leaves Barcelona for Paris or to reach Paris at the time. So, okay, it leaves at the time displayed. So this is the departing time. You understand? On the clock. Then at what time will the train arrive at? So the simple meaning, it has not yet arrived in Paris. So what time will it arrive? So if it leaves at this time, which is 10 minutes past 10, we shall need to know how much time will it spend on the road? How much time will it spend traveling? So we shall go to the map and look for Paris and Barcelona. The map, Paris and Barcelona, it's this route here that you see. This route up to the, look at the time that it has. It has 6 hours, 30 minutes. So simply meaning, if it leaves at 10 that, so we shall come here and we add. So this is, so to express this time in 12-hour system, we shall say 1640 is the same as, remember we said we subtract what? 12. So this is 440 a train from Amsterdam to Berlin arrived at 0 hours 12 minutes. At what time did the train leave Amsterdam? At, so now we are looking for backwards. It leaves Amsterdam for Berlin and arrived at this much time. At what time did it leave? So what is the departing time? At what time did it depart? So we shall take the arrival time. Just remember, duration equals to end minus start. So we are going to have the duration here. So we are looking for what time did it start. So this will be start time equals to duration. Sorry, end time, arrival minus start time will equal to end time minus the duration. So the end time, we have it as 0 minus what's our duration between Amsterdam and Berlin. We come here, look for Amsterdam is here to Berlin is 6 hours and 4 minutes. So we come and subtract. So this is 00, which is 24. Which is 24. So when we subtract this, it becomes 12 minus 4, you remain with 8. 24 minus 6, you remain with 18. So it left at that much time. Well, we said time has to be in 24 before you use it anyway. So we are saying the end time minus that time equals to duration. So we already have the duration as 6 hours 30 4 minutes. So that's the duration. So we substitute into the formula and we get the answer. duration equals to end time minus the start time. So we are looking for start time. When did it leave Amsterdam? So start time will equal to end time minus duration. The duration, we already have it as 6 hours 4 minutes. The time when it arrived, or the end time, we have it as 0. This 00, replace it with 24 to make sense out of it. So you come here, you get your answer as, I've put the 00 here, put 24 minus 6. So 12 minus 4, you get 8. 24 minus 6, you get 18. So this is the time when it left. Two point 2.5. The distance between Lyon and Barcelona, between Lyon and Barcelona is 192 kilometers. The driver claims that if he leaves at 16 hours 40 minutes from Lyon, travels at a speed of 80 kilometers, he will arrive at Barcelona before the sunset. If its sunset in Europe sets at 18 hours 55, verify the claim. So in other words, what we're going to look at, first and foremost, we need to know how much is expected on the road. So for him, he says he's going to drive at it. So we shall know how much time is he going to spend on the road. So let's look at that, because we have the distance and we have the speed. So we ask ourselves what will be the time. So using this formula here, first thing you need to do is to make time the subject, which will equal to distance over speed. So we have our distance 192, speed 80. When you divide that, we get 92 divided by 80. You've got the answer as 2, 2,4. These are hours. These hours, you need to change them to hours and minutes. We need it to become hours and minutes. So we have 2 full hours and 0,4 times what? 60. I'm changing this 0,4 to minutes, which becomes 24. So he will spend 2 hours and 24 minutes. This is what he's going to spend on the road. All right. So we are aiming at him reaching the place at 16:55. So the distance. Okay. So now, the driver claims that if the driver claims that if he leaves at this much, we'll reach there at this time, before this time. So we need to confirm. So if it's 16:40, it's going to spend 2 hours, 24 minutes, which is what? This is a 60. So it becomes an hour this other side, and the answer became 19. So the claim is what? Invalid. Because he does not beat the 18. Yes, he will be there around 9 minutes later. He'll be there around 9 minutes later. Yeah. So his claim is invalid. One, in this question here that we had to look for how much time is he going to spend, plus the time he leaves, the departing time. Time spent plus the the departing time. It should equal to 18. If it's not equal, then it's invalid. 2.3, we look at these kind of watches. Actually, these are wall clock, or yeah, they can also be wrist watches. Okay. Consider the clocks below. Okay, they are clocks. Which show different times during the day. That's afternoon, morning, afternoon and morning. Use the above clocks to answer the questions that follow. What time format is used in the above clocks? Explain why. Time format, we said is what? Of our system. Because it shows afternoon, and what? Morning. Someone else can say the system used is good what? Ana- Analog what? Analog system. Okay. Write down the time shown on clock D in watts. First and foremost, with D? This. They said it's in the morning. What's the time? It's coming to 3. So here it's a, you know how to count this. This is 5, 10, 15, 20, 25, 30, 35, 36, 37, 38, 39. So it's two what? 39. So how would you write this in words? Since it has passed 30 already, the minute hand has passed 30. Now we start saying 2. How many minutes remaining? So in this other one here, we are remaining with 20, 21 minutes to 3. Since it's the morning, you say what? 3 what? AM. So you can say in the morning. Express the time shown in clock, on clock C in 24-hour system. Time on clock C, it's afternoon. And when you look at it, it has just clocked what? 4. And a few minutes have passed. So this is what? 5, 6, and what? 7. So 7 minutes past 4. So it's 7 minutes what? Past 4. When you look at they say afternoon. So PM. This is the time from the clock. But right now, express the time shown on clock say in 24-hour system format, which is the digital format. So we shall come and add the 12 here and remove the PM. So this becomes 16. Please, here we don't write AM or PM. Why? It's 24-hour system, 24-hour format. 2.3.4. Mr. Mark and his family embarked on the road trip and left home at time shown on the on clock B and arrived home at the time shown on clock A. Determine the duration. Remember we said duration equals to end time minus the starting time. You would say arrival minus departure. So arrival time is on clock A. Departing time is on clock B. Let's go and we see clock A. Clock A, it talks of 12, 6, 7, 8. 8 minutes past 12. unknown. And the B is 10 minutes to 2. 10 minutes to 2, which is 150. So it's 150 morning. So remember, we said we change everything to 20 before you subtract because you know what you're going to do. What were you looking for? Duration, which is end time and start time. So you look for this end time. When did it arrive? When did it depart? So it arrived at 8 minutes past 12. You leave it a bit easy. If you change it to 24-hour system, this remains. Then 1 a.m. still also remains. So we subtract this. Now take note. 808 cannot subtract 50. What do? You borrow one from this other side. When you borrow, remember you're borrowing from hours, shifting them to minutes. So you've borrowed 60 minutes. So it becomes 68 minus 50. You remain with 18. So here you remember you took one, which is 11 minus what? 1. So it becomes what? 10. So this was the duration they spent. So they spent 10 hours, 18 minutes. 10 hours, 18 minutes. 10 hours, 18 minutes. If they were driving at a speed of 80 kilometers per hour, how far did they travel? Round your answer, the nearest. So how far? Now, when you look at how far and they have to round off to the nearest, so meaning we are looking for distance. And indeed, the formula they've given us distance equals to speed times time. So they've given us the speed as 8. Please, you substitute the same people. So times time. Now, the time has to be in hours. So it's 10, 18. This has to be divided by 60, which becomes what? 10 hours plus 18 divided by 60, 0, 3. So it's 10, these are the hours. So times 10, 3. So they spent how far? This is much. But they said round up to the nearest 10 kilometers. 10th, it's this one here. This one is 4. It's below 5. So the answer here becomes his wife claims that 2,500 will be enough for the return trip. The car's fuel consumption rate is 2.2 liters per 100 kilometers and costs, so and the fuel cost is 21 rands 50 cents per liter. Verify using the calculations whether her claim is valid. Now, what we're going to do, first and foremost, we look at what we call the return trip. Return trip simply meaning you're going to take the trip they covered times 2. So here we are. This is the distance that they have because the scenario doesn't talk of the distance here. We don't know the distance, so we are continuing with whatever we have. We're still looking under the same. We are dealing with the same scenario here. Ne? So C, we look for the distance, and we are saying the distance is this much. That's only one trip, so it's multiplied by 2. Why? I'm looking at the return. I'm looking for the return trip. So the distance covered here is 1,640. These are the kilometers. We are not interested in this. We're interested in how much fuel is needed. So we had to look for the distance covered to and fro. That's much. Then you need to know how much fuel is needed. So we are going to use the fuel consumption, which is 2 liters per. And so this simply means it will use 2.2 liters of fuel whenever it covers a distance of 100 kilometers. So it's going to cover a distance of 1,640 kilometers. How much fuel is it going to cover? We don't know. We leave it as a box. Cross multiply, and the answer became, I'm looking for the amount of fuel needed. And I will divide through by 100. So the fuel amount is 36,08. These are liters. These are liters. These are liters. So remember we are looking at the cost. So if they are going to use 36,80 liters, how much will it cost? So we shall multiply by 21 rands 50 cents. 21 rands 50 cents. So they will spend 775 rands 72 cents. So her claim is valid. The claim is valid. Had she said the wife claims that will be enough. Indeed, it will be enough because that's what, actually, it's more than enough. But as she said that 2,500 will be the cost, then we shall say invalid. But here she said it will be enough. Indeed, it's enough. It's more than enough. So the claim is valid. Though she's going to use less than that. She's going to use less than that. Let's look at question number 3. Question number 3 looks at area, perimeter. As we go on, we shall be looking at area, perimeter, among others. All right. We'll go straight to question number 3. The picture below shows the dimensions of the rectangular vector garden with 2 gates. The garden has a length of 35 feet and 17 feet respectively. It has a length and a width of 35 feet and 17 feet respectively. Simply meaning the length is 35 feet and the width is 17 feet. In that order, respectively means in that order. All right. Note the width of the small gate. Okay, when you look at the garden, this is it. Those dots are poles that are going. This line they present the round one represents a fence. Then these are the gates where one will enter from, and indeed this is a pathway where one goes through, and you go out from this other side. Okay. The width of the small gate is 9 meters, and while the width of the large gate is 18 meters. The garden will be fenced with a galvanized welded meshed wire Study the diagram and the, the information above and answer the questions that follow. Question number 1, 30.1.1. Explain the term perimeter according to the given context. Now we shall say, remember, perimeter is the total distance around a given shape. Now we shall say the total distance covering sorry, not covering, total distance around the vegetable garden. Total distance around the vegetable garden. The total distance, you can see length around the vegetable garden. Vegetable garden. State whether the dimensions of the garden are in metric or imperial. Remember, metric is where we look at kilometers, meter, centimeter, millimeter. Now, imperial, we look at miles. Imperial, we look at miles. We have yards. We have feet. We have inches. So we go and we check on the garden, the dimensions. They are in feet. So your answer is what? The measurements here are imperial. Measurements there are imperial. Another thing that I've forgotten about the perimeter. Perimeter, it's when you start from here, you come there, you come there, you come here, again you go. So the distance that you move from here, you go like that, you add. That's how we get the perimeter. When you move around a given shape of a given area. Around, which means outside. Meaning it's the same as the space occupied by the fence or boundary. All right, a boundary around a given shape or area. Determine the ratio of the width of the smaller gate to the large gate. Remember, they gave us those measurements. They're here. But what I wanted you to know, first and foremost, know its ratio of the smaller gate and the larger gate. The smaller gate, what's the width? We come back to the scenario here. We have it at 0.9 meters, and the large gate is what? 1.8. In that order, please. 0.9, is to 1,8. Simplify it, become 1 is to 2. 1 is to 2. Calculate the perimeter of the rectangular vegetable garden in feet. You may use the formula below. Now, someone might ask us, shall we count the gate? Yes. Why? We are looking at the vegetable, we are not looking at the fencing, but we are looking at the perimeter of the garden. They are saying it's supposed to be in feet. Remember, length is 35 feet. And the width is the 17 feet. Substitute. So we shall say perimeter equals to 2 into 35 plus 17. We are looking at perimeter. Perimeter needs us to have length. It's already given to us at 35. These are feet. Then we also need to have the width, which is 17 feet. So we need to substitute, and we shall say perimeter equals to 2 into length plus width. I'm using this other part here, which is 2 into 35 plus 17. See that? So we go straight forward, and you see you have the answer as 104. These are feet. So they are telling us, hence convert the perimeter of the garden to meters. So here we already have it as they are telling, if you only have 1 foot, you have an equivalence of 0,3048 meters. So for us, we have 104 feet. What will it be? We cross multiply. So the answer is to be telling us it has to be 3,16992. These are meters. In other words, it's the same as 31,70. All right. The roll of the mesh wire in the first roll is the mesh garden is sold in rolls of 120 millimeters. That's how long it is. But then the wire covers 10 meters. So 120 meters high and the length of 10 meters. So they ask you, determine the number of rolls of wire required to fence the rectangular. So before we do this, remember now this is when we are going to exclude, or this is when we are going to look at the gates. Why? Now you're bringing in the fence. Definitely you won't cover the face, the gates. So what we're going to do, total perimeter of the fence. So we already got the answer there up there, which way we said it was 35. Added the 17. We got the answer as what? These were feet. We changed them to meters. And the answer we got it as what? 31,6992. Here, we shall subtract the length, the width of the small gate, which is 0,9. And we shall subtract this width of the smaller gate, which is that much. So remain with 28,9992. So these are the meters that we need. So we shall divide this by 10 because it's sold in 10 meters. So we divide that by 10. You see, you find yourself that you made with 8,9992. But remember, these are rolls, so you cannot buy them in half. So the person will buy 3 10-meter what? Rolls. 3 of them, but the third one won't be fully used, but part of it will be used. They're asking you calculate the total cost of the bashware face. That's so really we've seen it that we need 3. 3 times 1,599. The answer that you get, equal to that much. Answer you get to equal to that much. Give one valid reason for putting a fence around the vegetable. And then the valid reason is known for the animals not to destroy the garden. If you have animals at home, you protect them. You protect the vegetable garden from those animals. So by putting what? A fence, not to destroy the garden, the livestock, not to destroy the garden. Then the other one, what would it be? Also to be neat, protect your garden from intruders. 3.2, when you look at 3.2, almost the same part that we're looking at. And here we have this diagram, yeah? Now this is from Mr. Malin intends to increase the area of his garden to plant more vegetable. The diagram below shows the dimensions of the existing garden and the alternations to the new garden. You understand? The existing is this blue one. Then these dotted ones are the extensions, which becomes the new garden. The garden has a circular garden bed with a diameter of 1.5 meters. Okay. Determine Mr. Malin's new length of the garden. Now you're taking the old plus the new one. So it's 11 plus 2. So the new length equals to the old plus the new. So we added that up. Take the area of the new garden in square meters. So the width is 6 meters and the new garden is 13. So let's go there and we say our length is 13. The width is 6. And the answer becomes 78. The answer becomes 78. Don't forget these are meters what? Squared. You show the units because even there they said in meters squared. So please, you don't forget the units. These are just meters, they're not squared because just we are adding. Here it's a square because we've multiplied 2 times. We've multiplied the meter from here and another meter here. So we multiply the 2, you get meter squared. Here we're just adding. You don't get anything. It remains the way it is. We go to 3.2.3. Martin stated that the percentage increase in the area of the new garden is 40%. So how are we going to get this? Number one, we shall need, number one, we need to know, because to get the percentage change, you need to get the new area. Allow me write it like this. Minus the old area. Everything divided by the old area times 100. Why? I'm looking for the percentage. Anyway, I have the new area. What about the old one? So I need to look for the old area, which will become L times what? B. Let's go back to the diagram. What's my old area? It's 11 by 5. So I'll come here, multiply 11 as length, 5 as width. And the answer becomes 55 meters what? Squared. So I have the old area. I'm good to go. I'm going to substitute. I'll say my new minus old divided by old times what? 100. The new is 78 minus 55, which is the old. I divide by 55. I multiply by 100. What answer do I end up having? 70 minus 23 divided by 55 times 100. So the answer here, you have it as 41.82%. So if you round it to, it's what they are saying is that the percentage increase. No, the answer is what? Invalid. Why? This is not 40%. And he said it's 40, and it's above 45, it's 40%. Then it will be valid. Why it's above? And he said it's less, it will be false. Incorrect. All right, let's look at question number 3.2.4. Show by calculations that the area of the circular garden bed is 1,767375 meters what? Squared. Remember, we are looking at the circular garden. And indeed, they have given us the circle here. They have given us the area. The area needs the radius. And in the scenario, remember, they told us that it has the diameter. So how to get the radius? Radius equals to diameter divided by 2. They told us the diameter was 1,2. The answer becomes 0. You see, the diameter is 1,5. Sorry, not 2. So we do that. 1, divided by 2. You have the answer 0,7. Now our radius is 0,7. So we come substitute in the formula. Squared. So 3,142 times 0,52 square equals to 1,767375. 3 marks. Did you look for the radius? Yes. Did you substitute correctly? Yes. Yes. Yes, let's look at question number 4 to be looking at volume and surface area. This comes in paper 2. Mr. Msondo is a farmer and Vumakala. He sells milk. The milk is stored in cylindrical or spherical containers that are sold to customers in 2 liters, 5 liters, 10 liters, 20 liters, and 25 liters. Pictures of the milk containers are shown below. This is a cylindrical and this is a spherical one. Sphere, it's like a ball. Cylindrical, it's like a tin, a can of Coke, a tin of baked beans, the cylinder. Now, so this height here is for the cylinder. The radius is for the sphere. All right, let's continue. These are the formulas given to you, and you may use them, or you might need to use them. Use the information above to answer the questions that follow. They are saying convert the 770 millimeters to meters. So here we are converting millimeters to meters. Remember, we have this. So it's accommodated here. 1, between kilometer and a meter we have 1,000. Between a meter and a centimeter we have 100. And between centimeter and millimeter we have a 10. So simply meaning we need to change the millimeter to centimeter, then we change it to meters. But when you look at it critically, you have tampered with approximately 1,000. When you look at it, it's 1,000. So what you're going to do, remember we said small to big, we need to divide, whereas big to small, we need to multiply. So we are from small to big, we're going to divide. Millimeters to centimeter to meters, we need to divide by 1,000. So we shall get the 770 divided by 1,000. The answer becomes 0.77 meters. All right. Determine the diameter of a spherical. Determine the diameter of a spherical milk container. As I showed you up here, the radius is for sphere and the height is for the cylinder. So remember, when we are looking for the diameter will equal to 2 times radius, which is the same as 2 times 2 times 73.5, and gives you the answer as 147 centimeters. 100. So define the term capacity. Capacity goes hand in hand with the volume, but capacity, we shall say, is the total amount of quantity a given container can carry or contain. You understand? Total amount of quantity a given container can hold or carry. If not, you might say in this context now, it will be this context now, it's going to be capacity is the amount of milk these containers can carry. Amount of the amount of the amount of the amount of milk these containers can carry. All right. That is it. Now they ask for volume. Actually, capacity in most cases it will be in the normal form of liters, milliliters. We take example of your geyser at home. The capacity, its capacity is measured in liters. But when we are performing or when we are calculating this capacity, we need to have volume. So it's from volume that we get capacity. Volume is the normal one, the calculations in centimeters cube. You understand? The space a given object takes. All right, here we go. Calculate the volume in centimeters cube of the spherical container. What we are going to do, we go back to our formulas here. What are we looking for? Volume of a sphere. So here we are. We are going to use this one, which says 4 times pi times r cubed, volume. So we write volume equals to 3,142. They told us times 4 times r cubed. All right, this is for a sphere. But we already know that the radius is already given, so it will be 4 times 3,142 times the radius that we already know as 73,5. It has to be cubed. What answer do you end up having? Let me do it here on my calculator. Have the answers. For 1,990,317,63 centimeters cubed. Centimeters cubed. Then we come to this. They say the capacity of the cylindrical container, is 60 liters. Determine the diameter of the container. Round off your answer to the nearest centimeter. Now, we need to ask ourselves, you well and good, they have capacity. And I told you its capacity comes from volume. So what we need to do is to change this capacity that we have, we change it back to volume. In this sense, because now they have told us centimeters. So it means we are going to change the liters to centimeters. You understand? Change the liters to centimeters. Then from here, 1 liter equals to 1,000 centimeters cubed. What about if you have 60 liters? What will it be? One liter equals to 1,000 centimeters what? Cube. So if you have 60 liters, what will it be? Multiply by 1,000. So you have 60,000 centimeters cubed. This is now our volume in the normal sense of. I'm using centimeters cubed because I need my answer to become centimeters. I keep it aside. Then I ask myself, okay, if this is the volume, how did they get it? Remember, we are looking for the volume of a cylindrical container. In our heads, we know that already. Volume of a cylindrical container equals to pi r squared h. Do I have the volume? Yes, it's 60,000 centimeters cubed equals the pi is a normal number that we know. Times, what are we looking for? We are looking for the diameter. Do we have the diameter of the cylindrical container? No. So the reason why I'm looking for the diameter. So the reason why we are looking for the diameter, it's the question. So we don't have the radius. Right? It was not given. So we leave it as square radius. What? Square times. We have the height. Remember with the height we said the height is 770 milliliters. Change it to The height, let's change it to centimeters, becomes divide by 10, you end up having 77 centimeters. This is the height. So I bring it here. So what I do, I take the normal number. 3,142 times 77 equals to 241,934. I will leave it like this. Times r squared should give us 60,000. I divide through by the same number on both sides. I divide through by the same number on both sides. It will die. Yeah, it will die. So I'm remaining with radius squared equals to, when I divide this other 60,000, I'll end up having, when I divide by 60,000, when I divide 60,000 by this number, I end up having 248,0015211. So on your calculator, because it's squared, I need to know what is r only. So it's because squared, I need to look for the square root on both sides. So I'll find the square root. So find the square root of the answer there. I end up having 15,74806.04. Now our radius is this much. I need to multiply by 2 because I'm looking for the diameter. So my diameter will become 31,96, which is approximate, because they said to the nearest centimeter. So we don't need the commas. So which is approximately 31 centimeter. When you look at this is 8 marks, and you ask yourself, how was it marked? Let's try to mark it and we see. Did you change the liters to centimeters cubed? Wonderful. Did you change from millimeters, the height? Did you change from millimeters to centimeters? Another mark. Did you understand this concept? 1 mark for that. Understanding this concept. Dividing, another mark. You applying the square root, 1 mark. Getting the right answer, 1 mark. Multiplying by 2, 1 mark. If I know mark is here. Take note, whenever something is missing, whenever there's something that you find, you need to find, you need to show it, please. Right? For example, here you knew liters have to become centimeters cubed. That's a mark. You knew that the height is in millimeters, it has to become centimeters. That's another mark. You understand? That's a mark. Then you substituting to get the formula, knowing what is there. You would get a mark for that. All right, that's how it was marked. Let's go to the second question. Next question. 4.1.6. Determine the number of 1.5 liter containers that would be filled with the milk from the cylindrical tank or cylindrical container. Remember, the cylindrical container is worth 60 liters. Someone wants, it comes with 1.15 liter containers. How many shall we get from there? It becomes 60 divided by 1.5. You have 41.5 liter what? 1.5 liter what? Containers. Okay, we look at this diagram 4.2. Let's look at it critically and we shall be. All right, this is a rectangular prism. of which we know. Within what comes in your head when the moment you say a rectangular prism, if they ask for volume, volume will always be. And if they ask for surface area, when it's closed, it will be 2 into L times B plus B times H plus L times what? H. If it's closed, but if it's open, it would depend on which side is open. It will depend on which side is open, then you have to manipulate it. All right? These are the formulas that I know I should remember when I look at a rectangular prism. All right. Mtondo makes a rectangular water troughs for troughs for his farm animals using concrete that is 5 centimeters thick. The diagram below shows the external dimensions of the rectangular trough with an open top. You see? So it's open. So this one here, if you're to look for the surface area, it simply means this side is closed. So it will be, let's say this is B, this is the height, and this is the length. So if this side is closed, so it will be B times the height, but these sides are 2 then. So we shall multiply by 2 plus this side equals to the, so they are also closed. So it means it's 2 into L times what? Height. Plus this side, the bottom. The bottom is closed, but the top is not there. So simply meaning it will be L times what? B. That's if they ask you for surface area of an open one. Why? The part here, it's basic, it's not there. Anyway, now we go on and you see these are the dimensions that we have. They are saying, wow, calculate the internal, use the diagram and the information to answer the questions that follow. The external dimensions are the external dimensions of the, so in most cases when we look at this, definitely this has to be the length, breadth, and the height. In most cases when you see it like, or sometimes they will write it like, they will put the times sign. The times sign means by. If it's given this order, you also understand it's this other form here. But these are external, outer dimensions. So, calculate the internal dimensions of the trough in centimeters. Now, how are we going to get the internal? Remember, the dimension from outside, from here to there, it won't be the same as you measure from inside here to there. Why? There's a thickness. There's a wall that already has 5 centimeters. So if the dimensions are 5 centimeters thick, that means you're going to subtract 10 on both sides. You understand? For the length, you're going to subtract 10 because we have the 5 this side and the 5 that side. The breadth is same story. You need to subtract the 10 here, 5 that side, 5 this side. The height, you only need to subtract 5. The bottom part is represented because the top one is nothing much. There's nothing here. All right, let's go and see. So we say the length will be 300 minus the 5 centimeter on one side minus another 5 centimeter, which will be 290. We go to the breadth, which is 190 centimeters. Also, you subtract 5 on one side, another 5 on the other side. So you remain with 180. Don't forget these are centimeters. In the height, we said we shall only subtract 5. Why? Because the other side on top, it's not covered. So it becomes 155. Don't forget these are centimeters. Don't forget that. All right. Hence, show by calculations that the internal volume capacity of the trough is 8,091,000 centimeters cubed. So they have given the formula here already. You remember we are looking for internal volume. So you will come here You say what's my new length? It's the breadth is 180 times 155. Did. That is the answer. We are using, they are saying hence. So simply meaning you're supposed to use the values that you find here. These are the values that we are supposed to use. These are the values you are supposed to use. Given that 1 gallon of paint covers approximately 280,000 centimeters squared, Mr. Nsondo claimed that 3 liters of paint will be enough to paint the internal surface area of the drum. Verify using calculations of his no, if his claim is correct. You may use the formula. They said you may use the formula, but when you look at the formula critically, it does not cater for what we said. It does not cater for an open. It does not cater for an open rectangular prism. So we said, yeah, this one here it is supposed to be one, not two. Why? One side is open. There are not two sides. So we only need to look for the area of only one side, which is the bottom. So if you having removed the two here, then these other ones are okay. So we start inserting. Remember they said internal surface area. That means we're using the internal measurements that we got. Together, the length, we've got it as 290. The breadth, we've got it as 180. And the height, we've got it as 155. These are centimeters. So these are the values that we got in the first place, which was these were the internal values. So now we come and we substitute them into where we see the L, we put the value. Remember, we removed this because it's an open area. It has an open end. So we shall say plus 2 into L, our length to 90, times the height, which is 55, plus I'm adding because this 2 here is the same as this. I've put it out. So which will become the breadth times. So that will become 290 times 180. 290 times 180 equals to 72 into 52,200 plus 146,170. So the total area that we need to cover here is supposed to be 198,300. What? So this is not rand, sorry. Centimeters what? Squared. So that is the area to be, the internal area to be covered, to be painted. To be painted. Now, we are not proving the area to be painted, but we need we need we need we need we need we need the paint to be used. So we need to know the area to be painted. This is what we are doing. All right, this is supposed to be the answer. When you multiply this very well, you have to get the answer as that much. Mm. Yeah. So this is the answer. This is the area to be painted, but we are not interested in the area. We are interested to prove that the 3 liters will be enough for the paint. Now we shall ask ourselves, look, the spread rate is given in gallons. You understand? 1 gallon. 1 gallon covers an area of 280,000. So for us, we have an area of 197,900. So what is it going to be? So we shall do that and we cross multiply and we find out the answer, which is we divide it by that much. So in divide, when you divide, you end up having 0.076. These are gallons. So change them to liters because her claim is 3 liters. So if 1 gallon equals to this much liters, what about this gallon? So we shall multiply by 3, 3,785. So the answer is 2,75 liters. Remember, they don't buy in half liters. So approximately what? 3 liters. So the claim is valid. The claim is valid. 1. we had to look for the area. You looked for the area. Having looked for the area, you had to look for how much, how much paint do you need? How much paint is what you got? You got it in gallons, you changed it in you changed the gallon, and you got your answer there. You verified the claim. 1, 2, 3, 4, 5, 6. Yeah. 8 what? 8. Look for the area. This is the area to be covered. This is the area to be covered. You get the area, you divide it by the spread rate, looking for the number of amount of paint. The amount of paint is in gallons. You've changed it to liters. You've got the answer, which is approximately. Then you've concluded. You've verified. That's how we get 7 to 8 marks. 7 to 8 marks. All right, someone will look at this. I have substituted for letter by letter 2, L, H, 2, W, H, and I got my answer as this. I put everything into the calculator. So I've looked for the area. Well and good. I have now the area to be painted. Now, I come on and I look for what we call the the spread rate. What we call the spread rate. The spread rate is 1 gallon. 1 gallon equals 1 gallon covers an area of 280,000 centimeters squared. I have an area of 197,900 centimeters squared. So how much paint do I need? So what I said, 1 gallon, but 1 gallon is the same as 3,785 liters. So I said, okay, that means that if I have 3,785 liters, I can cover an area of 280,000 centimeters squared. But now I have 197,900 centimeters squared. How much do I need to cover this much? So I came here, I did this, I cross multiplied the box multiplied with this. That's why I have this. Then this number here multiplied with this. That's why I have this now on top. Because I'm looking for this box here. I'm looking for this box. I'm looking for the answer in this box here. What do? I needed to divide by on both sides. In that I remained with the box on side. When I divided this, I ended up having 2,675 liters, which is approximately 3 liters. 3 liters, and I did need to conclude, which becomes valid. Why am I saying valid? Because the claim, it says 3 liters will be enough. You understand? Yes, indeed. We need 2,67, which is enough. So 3 liters are enough. So the conclusion is valid. So we have area, well and good. We've divided to look for the number of liters, well and good, from gallons. I multiplied that 1, 2, 3. I get this. I concluded as this. So my verification. So 1, 2, 3, 4, 5, 6, 7 could be your substitution here again. So 1, 2, 3, 4, 5, 6, and what? 7. Question number 5, let's look at question number 5. It's still under paper 2. It's measurement, but we are looking at what we call the BMI. BMI is used to tell the weight status and health status of a given person. It's usually in children. It's usually in children. But what does BMI stand for? It stands for body mass index. Body mass index. All right, let's look at this. Doctors determine a person's weight status by estimating or establishing their body mass index, the BMI. The World Health Organization says that the BMI is between 18.5 kilograms per meter squared and 24.9 kilograms per meter squared. Probably is a standard. Now, this person here, I think is, I'll call the person K. K is a 1.62 meter tall adult whose weight is 88 kilograms. Calculate the BMI. So we have the height, it's in meters already, and the mass is in kilogram. And they have given the formula already. So this is straightforward. We shall say 88 divided by 1.62. Don't forget it has to be what? Squared. So when you get that, your answer becomes 33, 33, 33,53. Don't forget the units. 33,53 kilogram per meter squared. The K struggles to breathe and consults her doctor for this problem. The doctor advises her to lose weight until the BMI reaches 25 kilograms per meter squared. Use the above formula to calculate the new weight in order to reach a target BMI. Now, let's take note of this. Now we have a BMI to reach. We have a BMI to reach. Definitely, the person is supposed to lose weight. You can't lose height. All right? So the height is already given in the scenario number 1, which is 5.1.1. They are telling us the height is 1.62 meters. Now we have the new BMI, which is 25 kilograms per meter squared. So what's missing? We need to know the mass in kilogram. So simple. What we are going to do, since BMI equals to mass kilogram over height in the meters, but it has to be what? Squared. So we ask ourselves now, if we have the BMI and we have the height, how are we going to get the mass? What do we need to do? We need to multiply. So simply meaning mass will equal to the BMI times the height. Height what? Squared. So which is, our new BMI is 25 times the height, which is 1.62. Remember, it has to be squared. So the mass has to become, the mass becomes 25 times 1.62 squared. The mass is 65. The mass is 65.61 what? Kilogram. They said the new weight. They didn't tell us round off to the nearest kilogram. So this is 65. All right. So they're telling us determine the total number of kilograms K lost. Remember, initially the person was 88. Initially, the person was 88. This is the initial grams. Now he has got the new weight. So we need to know how much the person lose. So it's supposed to be 88 minus the 65.1. 88 minus 65,1, and the person lost 22 kilograms, sorry, 22,39 kilograms. All right, why give one advice on how to lose weight? One, someone should eat healthy food, should avoid junk foods. Two, they can exercise every day. They can get they can subscribe for membership in a gym and they practice from there every day. All right. There are a lot of advices that you may give someone there. Set the healthy BMI range of a 12-year-old boy. They are telling us below shows the BMI for teenage girls and boys. Refer to the table and answer the following questions. Now we have the healthy BMI range, the overweight if BMI is good. Someone becomes overweight if the BMI goes beyond this. Now, severely overweight, it's greater than this. Then healthy, overweight, and severely overweight. Severely overweight, that becomes obese. Ne? Okay, so now we are looking at a 12-year-old boy. 12-year-old boy. You will come here. This is the age, 12 year. This side is boys. So it's this much. That's the range. So the range is 18 to 21. Okay. A 17-year-old girl has a BMI of 31 kilogram per meter square. Name the weight category. Weight category. Name the weight category where she falls. Weight category. Now, these are the categories that we have. She has a 31. Severely overweight. We shall say severely overweight. Severely overweight. 5.3, the growth chart below shows the BMI for girls. Refer to the growth chart and answer the questions. So these are the percentiles. These waves that we see, these are percentiles. Those are percentiles. Then they're saying Rachel is a 70-year-old girl whose BMI is in kilogram is on the 5th percentile. Estimate her BMI. So what we're going to do, number one, is to look for, you get a ruler. You get a ruler. Get a ruler. So having got a ruler, what you're going to do, because she's 17 years of age, come here, 17. Then you draw a straight line on 17. Sorry, 16. Draw a straight line. Right, you have to draw a straight line. Draw a straight line on 17. When does it touch the? Because this is a 50 percentile. Then you draw another line like that, and in that you read off the values here. So this is 20, 21, 22. So the BMI is approximately. So a 17-year, when does it touch this? Because they said it lies on the 50th percentile. So we are saying the BMI is 21 kilogram per meter square. That's how we do it. Yes, they're asking 3.2. Here we have the table to classify them. Say, hence determine Rachel's weight classification using the table to table is this one. Now we said it lies on 50 and we go 21. So here the health status is what? Normal. Why is it normal? It's in between 18,5 and 21. And the state classification is what? Normal. All right, refer to the growth chart and describe Rachel's BMI relationship to other girls. So we shall say Rachel's BMI is the median BMI, or you can say 50%. 50% of the girls BMI is above or below 21. We're talking of girls in her age. All right. Miss M, an educator and a coach for hockey team at Victoria West High School, wants to raise funds for the new hockey attire. She decides to host Miss with the beauty pageant. All interested girls collected the entry forms. The summary of the entry is shown below in table 1. The children height, Christian height must be at least the height must be 1.55 meters. Weight must be from 55 kg to 72 kg. Body mass index must be normal. So the N stands for normal. A, we shall find out in O, it's here. O only, it's obese. OW, it's overweight. Underweight, which is a U. The N stands for normal. That's the BMI. All right. So we look at this criteria also here. So they're asking us, calculate the missing value of A and B in the table above. The following formula may be used. So now they have removed it in the fraction form. Now they have written it in the linear form. What I wanted to do, remember, we have the triangle for distance, speed, and time. You can as well have the same triangle for BMI. You can have the same triangle for BMI. Don't lose hope. What you do it that way. Now, here I'll just use BMI equals to mass over height squared. You can do the same. All right. So let's go there and find value of A. What is it? Let's go to the table and find value of A. Wow. Value of A, we are looking for BMI, which is straightforward. So value of A, it's BMI, which says BMI equals to your mass divided by the height squared. But everything has to be in meters. So what's the mass under A? A, the mass is, oh man, they changed it, but the mass is supposed to be this one in kilometers. Kilograms, not kilometers. Mass, kilometers, and the height is supposed to be in meters. Okay. This is A. So the mass here, it's 44, and the height is 1.55. So we come back and we substitute, and we shall say 44 divided by 1.55. Don't forget you square. So here the answer goes, and we say 44 divided by 1.55 squared. So here the value of A is 18.31 kilogram per meter what? Squared. Let's look at the value of B. value of B. We go back to the chart, we check where B is. Wow, B is under the mass. So we are going to use this thing, this triangle here of mine that I've just drawn. So if you're looking for mass, what will it be? Mass will equal to B times height squared. The B stands for BMI. So we go back and we see under B, do we have the BMI? Yes, it's what? 30. The height is 1,55. So we shall come down here. BMI 30 times 1,55. Don't forget it's squared. So the answer then becomes 72, 08. These are kilograms. Why are they kilograms? Because we are looking for mass. (5.4) Mr. claims that some of the girls did not meet the criteria and disqualified them. Identify the entrant who did not meet the criteria and specify the reason for disqualification. So that's straightforward. Remember, they told us the height has to be 1,55 meters. The weight in between 55 kg to 72 kg. That's what they are. That's what they were. Look at the scenario here. It says for someone 72 kg and if that's a weight, the weight has to be, and the height has to be at least. So whoever exceeds this, you don't qualify. Whoever exceeds 72, you don't qualify. So here we come. This one has already been disqualified, though it's normal. And the BMI must be. Oh, wait, they said the height must be at least. Okay. No. This one's fine. At least. Simply meaning this is the minimum. So this is 62 normal. Why? The weight is in between. Okay. Then we have this. A was, we got the value as of A as 18. Sorry, we got the value of A as 18. We got the value of A as 18,3. 18,3 using the table here, 18,3. It's normal. It's 18, this is also okay. Normal. So people who didn't qualify is 1, 2, 3, 4. We have figure number 7, 8, 12, 14. They don't qualify. 7, 8, 12, 14. You can say 8, 12, and 14. Because they are over, they are overweight. They are overweight. She works and lives in Pearl. She is planning to visit her grandmother in Ladesmith and then her cousin in Port Elizabeth during the December holidays. She will spend a week at each of these places before driving back from Port Elizabeth to Pearl. Annexure A shows the strip chart of a route from Cape Town to Port, Port Elizabeth. Use the information in the next year, and answer the questions that follow. Number one, take note of this. The person we are looking at, the person stays in the person stays in Pearl, but she's planning on visiting the grandmother. The grandmother is in Lady Smith and a cousin in Port Elizabeth. So we are from Pearl. So we shall start from Pearl. We go to Lady Smith. Then eventually we go to PE. All right, let's look at the next step that they want us to look at. Write down the number of national roads shown on the strip map. This is the strip map that we see. National roads will start with N. We have N12. This is one. Scroll down. Wow, we have N2. This is 2. Then we have N1, which is what? 3. Is there any other national road? We don't have any other national road. The national roads that we see here are 3. All right, they said write down the number of, they didn't say list the national roads. So we have 3 national. Have 3 national. 3 national roads. Identify the national parks shown on this map. Identify. Because we'd have gone to the map and we identify, we take them off. But then anyway, you may mention them. All right, see the identification they said under the map, they say, note, NP represents or refers to a national park. So how many NPs do we see? Start from up here. We see there's one here. So 1 NP. We've got another NP here. So there are 2 so far. We come down, we look for NP. In other words, they're represented by these boxes. Where you see a box like that, there's a national park. You see that? Those boxes identify the national parks. So we go on and we say, identify the national park shown on the map. So we've said we have Ado, which is NP. Then we went to Tsikama. It's another NP. And the last one is Bontebok. NP. That's what we are identifying. All right. Determine the total distance from Cape Town to PE. We go to the next year. Now this is PE, Port Elizabeth. Where is it coming from? It comes from Cape Town. Oh, it's from 0 to 779 kilometers. So you write there and you say 779 what? Kilometers. Excuse me. The distance between Swollen Dam and Riversdale, we say we shall go to the map. We shall check it's from here to here. And we shall say, now, since Riversdale lies, you see on this line here, which is the same as this much. Also, Swatter lies on this line here, which is the same as this. This is 555. So we shall look for the difference between these two. That's why we had to subtract here, and the answer becomes kilometers. Or if you don't want, you can also use this other right-hand side, which is from 224, it has become 304. So how much distance is in between? Still, you get the same answer as what? 80. So we shall take it to be 304 minus 224, which the answer became 80 kilometers. Now we are calculating the distance between Pearl and Ladysmith using the National Road and R. So what we need to know, Pearl is here. So from Pearl to reach the other place, from Pearl, you need to come to Cape Town. So we are saying Pearl to Cape Town. Then Cape Town, you need to go up to Riversdale because you're going to Ladysmith. You cannot continue, so you turn it on the side. So plus Cape Town to Riversdale, then Riversdale to Ladysmith. So from Pearl to Cape Town, we are looking at 51 kilometers. It's 51. Then Cape Town to Riversdale, Cape Town 0 to Riversdale, 304. Then Riversdale to Ladysmith, from here to there, this is the distance, which is 82. So we add on 82. So we are saying Pearl to Cape Town, then Cape Town to Riversdale, then Riversdale to Ladysmith. So Pearl to Cape Town, we've already seen it as 51, plus Cape Town to Riversdale, we saw it as 304, plus Riversdale to Ladysmith, it's 82. Ask yourself, what answer do you end up having? You add them up. It's approximately 434. 1 plus 04 plus. So it's 437 kilometers. Don't forget that. Nabuthe will be driving a car that consumes, that uses, or that takes 5.5 liters for every 100 kilometers. The tank has a capacity of 55 liters. 55 liters. Determine the number of liters of fuel needed to travel from Pearl to Ladysmith. Pearl to Ladysmith. Remember, we've got the distance here. It was Pearl to Ladysmith. So look at the kilometers that we need to cover. So we shall ask ourselves, if 5.5 covers 100 kilometers, what about if I travel 437 kilometers? How much petrol do I need? I don't know. Leave it as a space. Simply meaning 100 multiplied with the space, giving us 5.5 times this. So divide by 100, I divide through by 100. So my empty box equals to 'It's the number of liters of fuel needed to travel from Pearl to Ladysmith. So we shall need 24,035. 035 what? Liters. This is less. 035 liters. 035 what? Liters. This is less. It's less than the full tank. Naboth states that she will require 2 tanks of fuel to reach Port Elizabeth from Pearl. Let's check because now we need to know the distance from Port Elizabeth to Pearl. But remember, from Pearl, she goes to Ladysmith. From Ladysmith, she will continue to PE. So the distance from here to this, we've already seen it as 400 kilometers. But then she would have to look at that. She has, okay, from Lady Smith, she goes to George because there's no straight road to PE. So she has to drive another 45 kilometers plus the 53. 45 is from here to there. This is 45. 45 from there to there, then from there to here, George. Then from George, you continue. So in between here, he has covered a distance of 45. We are looking for the, so at Pearl, she has to leave Pearl. Sorry, she has moved from Pearl to Lady Smith to visit the grandma. Then we cannot go back to Pearl. We are continuing to PE. So from Lady Smith to PE, what is the distance? So we shall add on the 45 we've seen there, plus the 53, then plus the 67. We are adding on the 45 from Lady Smith to Carlton Draw Stop. Then from Carlton Draw Stop, then we go to outdoor room. Here, this one here, which is 53. Then from this place here to this, we need to have 67. That's the distance I'm adding. 45 plus 53 plus 67 to George. Then from George to PE, it's going to be George to PE now, plus on, add on 321. Why? Because we are now on George, which is this, to PE, the line which is there. See? So we are looking for the distance. We are looking for the distance covered totally. Anyway, so we end up having so we end up having the distance covered as 900 just going. It says that we require 2 tanks to reach, but so from part to reach. So here we go. So now these are the distances covered. But they have told you each kilometer, sorry, if you're 100 kilometers, you take 5.5. So we divide through by 100. Divide through by 100 times 5,5. We are doing the same story, same thing like that. So we find out that approximately 55, so it's 51 liters. 51 liters. Yes, a claim might be incorrect or correct in the sense because you cannot drive on an empty tank. So as you see that it's dropping down, you need to refill. So I believe also the ones that I think that way would be correct. But you need to know what do you need to look for. We are looking for the number of liters before we say we conclude. So here we see that it will need 51 liters of fuel. Yet the car takes 55. So her statement is valid. All right. Nobukle wants to travel at an average, okay? Nobukle was traveling at an average speed of 120 kilometers per hour when using the national roads and 90 kilometers per hour on regional roads. She left the grandmother's place this is the departure time, at 15 hours. That's 3 in the afternoon, PM. Then to visit her cousin, use the information given to calculate the time when she will arrive at her cousin's place. So now she drives this on regional roads. So what is the distance on regional roads? That's what takes me back here. That she is at Lady Smith. This question has a lot of options because now if Lady Smith, she has to drive there to come there. So we need to know how much distance was it and how much time did she spend. So that's when we come in and we say, still you're going to add the 45 plus the 53 plus the 60, 67. So this is the distance covered on the regional roads, whereby we have 165 kilometers. But we are not interested in this. We need to know how much time was spent here. So if the average speed was 90, so time will equal to distance over speed. So here I will divide by 90. Why? I'll divide by 90 gives you 1,88. These are hours and minutes, but so we need to change it. So gives you 1,8. These are hours. So it's the same as 1 hour 50 minutes. That's on the regional road. Then what about the distance from George to PE? Because now that's when she's using, because on N1 she's driving using this in the normal speed. So the distance between George and PE, we go back and you see from here, because she has traveled now. She continue at this place, she just continue to come back here. You see? Here she has spent 1 hour 50 minutes. What about from here to PE? So we shall say the distance from here to PE is the same as 321. So we shall say 321 divided by 120. These are hours. Turn them into hours and minutes. So he spent 2 hours and 40 minutes. So if she leaves her place, or if she leaves the grandma's place and she spends all this much time on the road, what time will what time will she reach? So simply meaning it has to be 3 plus 1 hour, 50 minutes, and 2 hours, 2 hours, 40 minutes. So all in all, how much will it be? Right. Let's look at this. Question number 7. Zanokuhle is planning to take the family during December holidays to Robben Island. Zanokuhle lives in Pretoria and her family lives in Durban. She's going to drive to from Pretoria to Durban, and they'll have to take a flight from Durban to Cape Town. The next chart B shows the road map of South Africa. All right, then we're going to use the next chart to answer the question. This is the next chart here. All right. Yes, it shows the roads. The measurements are not supposed to be there. All right. We shall continue and we shall see. We measure the distance between Pretoria and the Durban. Measure the distance between Pretoria and Durban. So you measure the distance between Pretoria and Durban, and you take this stretch distance here. Probably you may get, let's say this is around 31 millimeters. You come and measure from here up to there. You also get, let's say, around, you've measured the distance between these two in millimeters. Maybe you get 15 millimeters. So you have a measurement, the distance between the places, and the distance for the scale. So here you will come and say the scale that you've just measured, this one here, 15 millimeters, are equivalent to 300 kilometers. So we shall come here and say 15 millimeters, they give me 300 kilometers. What about if I have the 300, you see, 310, 300 and the sorry, let's take it to be 31, sorry, not 310, 31. So here we shall say, what about if I have 31 millimeters? What will it give me in real life? So the on top here, this was a scale. But this is the distance you've measured on the map between the two places, between Pretoria and Durban. All right. So now if it's like this, what do? We cross multiply, which means 300 times the 31 will equal to 15Q. Divide through by 15. Divide through by 15. This 15 goes with that. 300 times 31, you get 9,000. 9,300. These are the values that we have. So we divide through by 15. So it becomes 620 kilometers. 620 kilometers. So this is the distance between Pretoria and Durban, according to our measurements. Please, you measure and you find out the answer. All right. Zamakuse will travel from Pretoria to Durban via Harry Smith. Write down the detailed set of directions to show Zamokuse's trip. Now, set of directions. Here we expect you to mention the road they are going to use, the direction they are going to use. For example, we are here on this map here. They are traveling from Pretoria to Durban using Harry Smith Road. So what I expect you to do for me, one, you are from Pretoria. What do? You come up to Johannesburg using what? N1. So in your description, you write use N1 from Pretoria to Johannesburg. Then, remember now you're in Johannesburg. Then from Johannesburg, you need to use N3 up to Harrismith. Mind you, you mentioned that. Then use N3 from Johannesburg to Harrismith. So you see that? Then do you stop at that? No, you're going to Durban. Then using N3, this will continue up to Pietermaritzburg. You can say through Pietermaritzburg to Durban. I'm sorry for using short names, but I wanted to fit. And so you mentioned the roads that you're using and the places that you are passing. The road from where to where, you mentioned that, and where is it taking you? All right, let's continue. Zanoko was driving at an average speed of 90 kilometers. She left her place at 5 a.m. She decided to take 30 minutes. She decided to take 30 minutes relaxing break at Smith. She claims that she is going to arrive in Durban at exactly 1956. Use the information given and verify whether her claim is correct. You may use the formula speed equals to distance over time, or speed equals to distance divided by time. So here we go. Number one, we need to know she has been traveling at this distance here. 2, Harrismith. This is the first thing that you're going to do. You understand? So we need to know at what time does she reach Harrismith. But before we find the time, because time, if you have to find time, we shall need distance divided by speed. You see? By the way, you can also do it this other way around. Because the distance from Pretoria to Durban, it's this much. So we can find out how much time will she spend. So she has to spend, but the distance is this much. She has been driving at 90. What time is it? Total time spent. Okay, 2 divided by 90. We see it as 6.89. These are hours. Change them to minutes. Hours and minutes. So we do that. We divide by, sorry, these are 6 hours. 6 hours and 6 hours. 6 hours, 53 minutes. How did I get this? I took this 6, these are hours. Then we remain with 0.89. Multiply this by 60 because I want it to become minutes. When I multiply it by 60, becomes 53.4. Just take 53. So this is the time she has spent. But remember, she's going to take 30 minutes break. So we add on the 30 minutes. So in other words, this is she will spend around, because this is this is 3, this is 8. 8, we need only 60 to make it, so the 2 remains here. So she has spent 7 hours, 23 minutes. So now, if she left at 5 p.m., 7 hours plus 23. What do you end up having? This is what? 12, 23. So it won't be the time. So it's not valid, isn't it? It's invalid. If, okay, 7.8, if a plane can fly at a minimum average speed of 740 kilometers per hour, and the distance between Durban and Cape Town is approximately 1,700 and 700 kilometers, determine the time taken by the flight, time taken to fly from Durban to Cape Town. You may use the formula below, time taken. So we are saying time equals to distance over speed. The distance given to us is that much over the speed of 740. So you see, you get the answers 2,297, which is approximately 2, these are hours. So what are you going to do? These are 2 full hours plus the 0.30 times 60. Why? Because I want this to become minutes. So this will become 2 hours, 18 minutes. So that's the time they're going to spend. That's the time they are going to spend. Determine the probability as a percentage of finding an airport at George. Let's go to the graph. George is here. This is George, and indeed there's an airport there. So as a percentage, this becomes 100%, which is what we say what possible. The answer is what? Possible. If you don't say possible, you can say it's what? Certain. Sure. It's 100%. Let's look at question number 8. Number 8, it's a floor plan. When you look at the floor plan, actually a floor plan is a layout of how a house will look like in the future. All right? It shows where the kitchen will be, the bedroom, toilet, living room, the garage, if there's a garage, what's there. That's a floor plan. It's a floor plan, a major layout of. All right. RDP houses are built to assist low-income earners. RDP houses are built to assist low-income earners. RDP houses are built to assist low-income earners with proper houses. Mr. Nyandeni visited Uruduwai Unit L to check the progress of the construction of his parents' home. The floor plan of the house. Now, this is how the house will look like. All right. That's how the house will look like. Take note, we have a compass there. These are measurements. These measurements are in millimeters. Okay. Determine the number of interior doors shown on the floor plan. Interior, those that are inside. So we shall start by saying, interior doors. Interior doors, we have 1, 2, and 3. 1, 2, and 3. RDP houses are built to assist low-income earners with proper houses. Mr. Nyandin visited one of the units to check on the progress of the construction of his parents' house. A floor plan. What's a floor plan? A floor plan, we always say, it's a layout of how a house will look like. All right, probably it might have a compass. Some others have scales, depending on which kind of floor plan is given to you. So we have measurements. These are measurements that we see on top. These ones here, but they're in millimeters. All right. We look at question number one. Question number one says determine the number of interior doors. Determine the number of interior doors that are shown on the floor plan. Interior simply meaning the ones which are inside. So we have one that's inside, two, and three. So we have three interior doors. So here we have three. We have three doors. Give the general direction of the bedroom one from the living room, meaning you're in the living room, you're going to bedroom one, living room two, bedroom one. Yes, this is our campus. The campus has north. So this is west, south, and east. So if you bedroom one from the living room, that means if you're in the living room, where is bedroom one? So bedroom one is in the northeast. Our general direction here is northeast. Name the room that has the same floor plan as bedroom two. The same floor area, same floor area as bedroom two. Let's come here. Bedroom two is 3,550. These are millimeters. What about this side here from here to there? What's the bedroom? Let's go and we see. Oh, it's the same. It's the same. 3,550. So this is bedroom two. So we are looking for a room that has the same measurements as this. Same measurements. Let's come. We shall start with bedroom. Living room. Yes, living room. Yes, it has this much. What about from there to here? What is it? We check up. Oh, it's the same story. So one of the rooms, we can say living room. Let's see. The kitchen, no. This number is different. Bedroom two. This number is different from it. So the living room shares the same area as bedroom two. Living. Give the names of the rooms that are facing west. In other words, those ones that are on the western side. On the west, we said this is west. So if you draw a compass in here, you draw the compass in between the house. So which one is on the west? These are the rooms. We have the kitchen, the toilet, and the living room. We shall say, we said we have the kitchen, we have the bathroom, call it the toilet, and we have the living room. Sorry, 8.2. Study the sitting plan of a airplane below. Study the sitting plan of the airplane below that is going to be used by Kubeka's family when traveling from Durban to Gauteng. Sitting plan of the airplane, it's this one here. Define the sitting plan. So here we shall say sitting plan is the drawing show sit in the airplane. Showing sits in the airplane, it's a drawing showing. You can say it shows the sitting arrangement of how people are going to sit. How many exit doors are indicated on the sitting plan? Now, unfortunately, we don't see any symbol to show, but the exit doors we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 exit doors. 8 exit doors. Write down the number of passenger seats in the plane. Oh, so here we go, number of passenger seats in the plane. Now, what do you get? This was just showing you that this is column A, B, C, D, E, F, but still these are seats. Eh? So we're going to count. We shall see 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 3 plus 9 again times what? 3. This is the first class here. Then we can count these ones. 1, 2, 3, 4, 5, 6 plus 6 plus, let's count 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 18 times 3 times 2. We're going to add up all the seats now. So 9 times 3 times 2, we have 54. 54 plus the 6 plus 18 times 3 times 2. This is 60 plus that, which is 168 seats. 168 seats. All right. 8.2.4, the actual length of the airplane. Actual length of the airplane from the cockpit to the passenger cabin is given as below. As 50 meters. So the scale of the plan is 1:200. Calculate the length of the plane on the plan. Plan, this is what? Paper. Then actual, the moment you hear the actual, this is in what? In real life. So we call out the scale, which is 1:200. The left is on paper, and the right is in real life. So in real life, this plane is 50 meters. What is it on paper? You remember on paper, we should all have millimeters or centimeters. These are meters. We are going to cross multiply. Cross multiply 200 times A. You get 200A equals 1 times 50. Remember, these are meters. So since we're looking for the value of A, we divide through by 200. Divide through by 200. So the A equals to, this is 0.25. These are meters. Change them to millimeters, multiply by 1,000. The answer becomes 250 what? Millimeters. If you wanted them to become centimeters, it would be 25 centimeters. Mr. Kubeka's son has been allowed to has been allocated a seat in the 8th row, second column. From the left, name the seat number he will be seated. So they have told us 8th row, second column. So these are columns. When we go down, these are columns. Then these are the rows. So we are in row number 8, second column. So it's supposed to be here, which is what? B8. You see? So So the seat number is B8 on the left. That's what they say. So it's B8 on the left. From the left. Mr. Kubeka's wife wants to sit in any seat next to the window. Mention one reason why she chooses to sit next to the window. One, people like it when it's to view. To view what? To have a clearer view. Others might sit there. In case of emergency, they can easily escape. All right. Give one possible reason why Mr. Kubeka decided to use airplane to travel to Gauteng. Advantages of using an airplane, aeroplane. It's supposed to be one, it's fast. Two, it's convenient. It's convenient. Three, comfortability. Among other reasons, you pick one. Why would you use a plane over a bus? The family left King Shah Airport at 9:30 and arrived at OR Tambo at 10:40. Take the average speed the airplane was traveling at if the flight distance was 478 kilometers. One, we need to know how much time was because we are going to calculate speed. And remember, speed equals to distance over time. We already have the distance, it's this much. What we don't have, it's what? The time. So time will equal to the duration they spent, which is the end time minus the start time. The end time they ended or they arrived at 10:40 minus 9 and that this is 1 hour and 10 minutes. 1 hour, 10 minutes. So we change everything to hours. So 1 hour plus 10 over 60. What do you end up having? You have 1,1666 recurring. I will leave it like that. So these are the hours they use. This is the time. So here we go. So speed now, we have the distance divided by 1,167 as our time. It's the speed of the airplane. We look at question number 9. Architects make use of models of buildings so that they are able to sell their ideas as well as convey what the building will look like once it has been built. The diagram below shows the gable roof and the net diagram of the small tuck shop. Use the diagram and the information above to answer the questions that follow. The gable roof structure, this is how it looks like. This triangle part of it, that's what we call the gable. And the net diagram of the gable house is how it looks like. All right. If the net diagram was constructed using a scale 1:250, was the net diagram going to be bigger or smaller than the above net diagram? Definitely it will have to be bigger. Why? 250 is more than 100. So simply meaning the diagram will reduce or enlarge by 250. So here we say it's gonna be big, 120, sorry, 250 versus 100. So 250 is bigger than 100. If it was less than 100, then it would be smaller. Use the scale 1:100 to determine the actual length in meters of the tuck shop. Length of the tuck shop. Let's go and we see. The length of the tuck shop, I believe it's going to be from here to here. These are walls that are going to be standing up. So we cannot add also 24. 24 millimeters. This will be the height of this part here. From here up to there, it's 24. Because if you fold from here up to there, it's the length, which is the 70. So when you fold this upwards, so this becomes the length, this becomes up, this becomes the height. This from here up to there, it's the breadth, which is 50. So from here up to there, it's the 50 millimeters. All right. They want us to change the length into actual. So we said left is always on paper. The left-hand side is always on paper. Then 100 is the actual measurement. So if on paper it's 70, on paper it's 70 millimeters, what will it be in actual cells? We don't know. Let's leave it as a cross multiply 100 times 70 will give me the A that we are looking for. But remember, these are 70 millimeters. So the answer you get here, this will be 7,000 millimeters. Why? We had millimeters. But we don't want millimeters. We want it to be actual. So millimeters, change them to meters. Divide by 1,000. And the answer becomes 7 meters. 7 meters. All right. If the gable has 0.5 meters hung on either side, determine the value of A, the actual width of the one side of the gable tuck shop. So here we are. So they want us to get this side from here up to here. But remember, it has a hang, like it goes off the wall a little bit. This small space here that we see from here up to there. That's what we call the hang. Either. But how big is it? In actual sense is 0.5 meters. So what about if it's from here up to there before the gabi? It's this distance that we have here. So it's millimeters. But remember, this is on what? On paper. And the question wants you to have the actual. So you should change this to actual using the same scale that we have here. So let's go there and we see. Shall say 1:100. What about the 26.93? What will it be? I'm changing it to actual length. So we shall multiply that, which is 26.93 times 100. So this will become 26.93. These are millimeters. Divide by 1,000 becomes meters, which is 2.6. This is only one side. So we add on the 0.5 meters, which will give you 3, gives you 3,193. 3,193. These are the meters. This one why I'm giving you in meters, they wanted the actual width. All right. Here I had to change it to actual. So this is it. Then I changed it to meters. I I added in a 0.5 there. All right. We look at packaging. Packaging, this one we call it lengthwise and this is widthwise. All right. Oh, we shall see what we go. Okay. Packaging. A company produces rechargeable LED lantern lights and packs them in small rectangular boxes as shown below. The small boxes are then packed into large boxes for transportation. Pictures of small rectangular boxes. This is how it looks like, the picture, not the diagram. Now, these are the diagrams. These are pictures. Okay. The dimension of the boxes. The big box has a 60 centimeter width of 48 centimeters, height of 24 centimeters. Small box has a length of 22 centimeters, width of 12 centimeters, and a height of 12 centimeters. The small boxes are packed into the large boxes using these two options. When you look at option number one, the length of the small box, we shall call it LS, is facing the length of the big box, which we shall call LB. So if you're to find out how many small boxes, because here we're going to find out how many feet on the long side, how many feet on the short side. So they're saying verify using calculations which of the two options will be most cost effective to pack in the small boxes. Cost effective simply meaning it will be less expensive. Less expensive. In other words, it has to take more small boxes. Cost effective, we are looking for more. Which option would take more small boxes? That's what you're looking for. Anyway, let's start. If you're to use option one, we are taking the length of a bigger box divided by the length of the smaller box. What do we have? So we go back and we remind ourselves the length of the smaller box is 60. The length of the smaller box is 22. So we shall come here and we say 60 divided by 22. What answer do we get? It's 2,727. But we can't have a comma box. So here we shall need 2. All right. Then we go to how many will fit on the short side from here to there. How many will fit? Because we've already seen from here up to there lengthwise. We've already seen that. What about the width? So width, we shall say width of the bigger box divided by the width of the smaller box, which will become 48 divided by 12. 48 divided by 12. 48 divided by 12, which is 4. So on the short side, we shall take 4 there. What about height-wise? When we go up, so it will be height of the big box divided by the height of the smaller box, which will be, here we are looking for how many layers. So it will be 24 divided by 12, which is 2. So option 1, all in all, how many boxes do we take? We take 2 by 4 by 2, which gives us 16 small boxes. This is option 1. Let's look at option 2. Option 2 changes a little bit because now we see the width of the small box is facing the length of the bigger box. So how are we going to get how many are going to fit here? If I take the length of the bigger box divided by the width of the smaller box, that's what we are going to do. So here it changes a little bit. Length of the bigger box divided by the width of the smaller box. Length, we said it was what? 60. Width of the smaller box is what? 12. It becomes 5. Continue, we shall say here now width of the bigger box divided by the length of the smaller box, which is 48 divided by 22. The height will remain height of the bigger box divided by the height of the smaller box, which became 24 divided by 2. And answer became 2. 48 divided by 2, we have the answer as 2,1818. So here we only have 2 boxes. So in option 2, we have 5 by 2 by 2, which is 20. 20 small boxes can be packed in option 2. So option 2 is cost what? Effective. The picture below shows 30 trolleys the company uses to transport large boxes to the delivery vans packed. So these trolleys are packed in 3 columns by 10 rows. So 10 of them they pack. So in other words, these are 30. Because if each column has 10, 3 times they are 30, all in all. Anyway, so the one has to find out how many, the 30 trolleys are packed using 3 by 10 arrangement. Calculate in meters squared the floor space needed to store the trolley. You may use the area equals. So first and foremost, we need to find out the length, because it's not given, and we shall find out the width. So the length will be longwise, like from here going that side, and width-wise it would be from here coming this other side. So we shall look first and foremost length. Mainly they are 10, but each will leave a space of 30 centimeters. You know, they are packed into each other, 30 centimeters. So 9 of them, it will be 96 plus 30 times 9. Why do I get 36? Because each has 96 centimeters, which is okay. So one of the trolley, it will have to maintain its length. But then when they enter inside each other, they leave a space of 30 centimeters each. So how many trolleys are going to enter into each other? They are 9. So the lengthwise, it will be 96 plus 3 times 9. So the length will become 366. These are centimeters. Yes, sir. So that's the length. What about the width? The width when they are packed like this, that one will be so simple. Why? Each will take 50 centimeters. 50, so it becomes 50 times 3, which becomes 150 centimeters. Take note, the area is supposed to be in meters. What do you do? Change the length you've got into meters, change the width into meters. So our length now becomes 3,66 meters, and the breadth becomes, or width becomes 1,5 meters. So area will equal to 3,66 meters. 3,66 0.66 times 1.5. 5.9 meters squared. 5.9, 5.49 meters squared. That's how we get it. Use the actual length in option 2 to determine the scale in the form of 1 is 2. I'll give you a number. If the measured length is 8.5 centimeters. Now we are determining the scale. The scale we are determining is a ratio scale. Remember, ratio scale has the left and has a right side. So the left, it's what we have on paper or on the plan. And the right, this is what we have in actual sales. You understand? So on paper here, they have told us they measured 8.5. These are centimeters. Are equivalent to, in real life, we come here, option, we say option 2, which is this other side. It's 25.5 meters. 25.5 meters. So the big unit gives to the small. So the meters have to change into centimeters. So multiply by 100. So remain with 8.5 is to 255. But we need it to start with a 1. So we divide through by 8.5. 8.5. Here, this goes. You remain with 1 is 2. This is 300. Sorry. Sorry. It's supposed to have a 0 here. Divide by 8.5. We have the answers. The scale is 1 is to 300. This is the answer. 9.4.2. Mr. Andres intends to use the option with the minimum square meters. Use the calculation to determine which option you will recommend. Minimum. Which one has the smallest area? So Andres to choose. So here we go. These are the diagrams that you're looking at. Option 1. If you are to look at option 1, it has how many sections? It has 1, 2, 3, 4. But they all have the same units. So what we're going to do, let's look at area. Only one section, which will be 6.8 times 10.6. We put it down and say what answer do you end up having? This is only for one section, so multiply it by 4. So option A takes 288, comma, the rate 2. These are meters, what? Square. That's option 1. Let's come to option 2. Option 2, it's already measured. Everything is there. So for it is straightforward. L times B, which is 25.5 times 9. which is 299. Mm-mm, 229. 229, comma 5. 229, comma 5 meters squared. So which option we shall we have? It shall have option 2. Option 2 will take minimum, a minimum space. So here we are doing question number 9 point. So here we say which option? We shall say option 2. Determine the number of wires to be connected in the plug. Let's look at this other question here. Wires. Now each part that you see here, this is a wire. You have 1, 2, 3, 4, 5, 6, 7. So there are 7 wires. Seven wires. When we come to this, write down the number of plugs that should be connected for the stop lights. The stop lights, you come here. We have one stop here. The stop lights. You see it? Any other? There is no any other. So we shall say it's 1. It 'Identify the color of wire from the rear fog lights. Rear fog lights. We say it's what? Blue. Explain the importance of the tail lights on two. It's to indicate for the 9.6. Purity cereal box has the following dimensions: length 14.5 centimeters, breadth 5 centimeters, and the height of 193 millimeters. Inside the box, there is a foil bag containing the cereal. The length and the length of the bag is 96.55% of the length of the box, and the height is 7% shorter than the box. The breadth of the bag at the bottom is 4 centimeters. Below is a picture of the net box opened up. Use the following formula. Calculate the amount of cardboard in centimeters needed to make one box. Now, here we go. The net is the sketch of the diagram. So this is what we need. So we're going to calculate the length, total length. It would have been, you would have used surface area, remember that? Which is 2 into L. But this one here is a different. I've given it because now this surface area does not get because this one is price also here. So this one does not work here. Anyway, let's continue now. In our mere understanding, we shall have to say that uh, we need the area of C. C by how many times? So C, it will be 4 times, 4 C's. Plus, how many D's do we have? We have 4 D's. You see that? Then we go on and we say, the C's are already there. The C's are already there. Then the B's will be 2 B's plus how many A's? We need 2 A's and 1 E. That's what we need to do. But they have already given that if you only have 1 C equals to this much, if you have 1 D equals to that much. All right, let's go and see. But they didn't give us the area for A and the B. All right, so we are going to do that. We are going to add them up. First and foremost, we may look for the area of A because I'm here looking because this is length. So, but remember they told us the length of the box is 14, 14, these are centimeters. The height will be 19,3 centimeters. So area of only A, area of A will equal to L times B, which is probably 19 times 10,5. That's A, right? Area of A is the centimeters, what? Squared. That's A of A. Then we go to area of B. B, we are going to analyze it also. This is breadth from there to there. Then the height. So what's the breadth? When we come here, they told us it's 5 centimeters. So area of B will equal to 19,3 times what? 5, which equals to 96,5 centimeters squared. So we have, now we can continue now and we substitute. What we need to know is calculate the amount of cardboard in centimeter needed to make one box. That's what so we are going to add all the areas of all these small pieces around. All right. So I'll start with, we say, we analyzed that we need 2 A's. So I will say 2 times the area of A, which is 279,85, plus we need 2 B's. 2 times the area of 96,5, plus how many C's do we need? We need 4 C's because we saw we have 4 C's here, né? So it will be 4 times the area of only 1 C, which is 43,5, plus how many D's do we need? We saw also there are 4. This one here we have 1, 2, 3, 4. So we say 4 times the area of only 1 D, which is 12, plus what's remaining now? We finish the B's, we finish the D's, the C's are finished. E, it's only 1, and they have told us it's 11. get 11,6. Put this in your calculator and you see what you get. When you put everything in, you get that much. 988.3 centimeters squared. Okay. All right. Now let's look at this. 9.6.2. The cardboard is cut from a sheet that is 90 centimeters by 90 centimeters. Determine the number of boxes that can be cut out of this sheet. Assume that 3 centimeters, C is 3 centimeters wide, and E is 1 centimeter what? Wide. So we are going to cut this 1 centimeter wide, and here we have 3. So we need to know if you're to how long will it be when if you're to add it up like that from top to bottom. How long is it going to be? Sorry about that. And how long will it be like this? You know, you've not considered those cutting small ones. So I'm here looking at this. This is already what? 19.3 centimeters. Then on top there we have, they told us it's 3 centimeters wide. Also bottom here we see 3 centimeters wide. You know, this one you're taking 3 centimeters wide because this one is shorter than, so everything is combined into one. So what about how long will it be? So we shall start with this one portion here. 1 plus from here up to there, it's 14. Then from here up to there, it's what? 5. Then again another 14 plus another 5, which becomes 1 plus 2 into 14 plus 2 into 5. Understand? That's what we need to know. So lengthwise, what's the length and what's the width? This would be the width. Right. So the length will be 1 plus 2 into length equals to 40. Whereas the width is going to be 19.4, 10.3, sorry, plus 6, it's 25, the width is 25.3. The reason why I need to do this because these cuttings will appear there, yes, well and good, but how many, if it's a full box without the cutting, how long is it and how wide will it be? So now I'm good to go. I'll go, yeah, lengthwise 90 divided by our 40 that we saw. So 90 divided by 40, you have 2.2. In other words, on the long side, we shall only need 2. Okay. Remember, the sheet is 90 by 90. So the other 90 is going to be divided by our width, which we saw as 25.3. 25,3. So 90 divided by 25,3. Yeah, you end up having 3,56, which is what? 3. So all in one sheet, we shall need 2 times 3, which are 6 what? Boxes. 2 on the short side, 3 on the long side. All right. A sheet of cardboard costs 5 rand per meter squared. Calculate the cost of making the number of boxes that you calculated it. 9. So, remember each, okay, we said there are 6 boxes, but each takes an area of that much, which means it covers an area of 592. These are centimeters what? Squared. They are charging in meters squared. So we change this to meters squared by dividing by what? 100 squared. That's much that they need there times 5 rand. The answer becomes around 96 cents. All right, here we go. In order the company to save money, the difference between volume of the box and the volume of the foil bag must be 350. Must be between 350 centimeters cubed and 400 centimeters cubed. Assume the foil bag has a rectangular prism. Verify by showing calculations. So we are looking at the difference between volume of the box and the volume of the foil. So for the box, we need to put it down. We are saying it's L times B times H. But let's go up there and we see these are the measurements of the box. As you see there, 14,5 as a length, 5 as a breadth, and the height of 193 millimeters. So we shall come here and say length 14,5 times 5 times 19,3. Remember the height was 190 millimeters. We want it to become centimeters. So we divided by that and we got this answer. So this is the height. That's why we have this much. So put the answer down there. So the volume we have here is what? 1,399, These are centimeters what? Cubed. Then volume of the foil. We need length, breadth, and the height. But when you look at the scenario they have told you, the foil one, they are talking of the length of the bag, the foil bag, you know, foil bag. So its length is 96.55 of. So here we shall say its length is 96.55 times the length of the box which you have. You go to the height. The height, they say, the height of the box is 7% shorter than the box. The height of the box is 7% shorter than the box. The height of the part is shorter than the box. So simply meaning, if 7% shorter than the box, that means it's 93% of the height. So we shall come here and we say 93. Remember, this is percentage, 93% of the height that we have, which is 19.3. Then the breadth, they said, the breadth, they say, the breadth of the bag is of the bottom is 4 centimeters. So here we are saying the breadth is 4 centimeters. This one don't need to change. So we need to look for this. Look for that. 93 to 96 times. Divided by 100. So the height here is 13.97, which is approximately what? 14 the centimeters. So the height is 17.95 centimeters. So the volume of the foil will become now 14 times 17 times the 4. We have 1,005 centimeters what? Square. I don't know how we are looking at the difference between the two. We shall subtract foil. It's 394, comma. Yeah, it's fine. Satisfies. You can say it. Satisfies.